Hello, Ninja Warriors. Welcome to yet another power packed session. And as you know, that in this particular series, we are solving all the problems from JEE Main 2024 April attempt. Okay, so let me just dive into today's session. Before that, I would like to tell you about today's chapter. So you can see today's chapter is all about application of derivatives. Now, this is a chapter which, if I talk about till 2023, it was amongst a high weighted chapter. But as you can see, that in January attempt there were 6 questions, and in April attempt there were 15 questions. So there is a big discrepancy in January and April attempt. As you all know that in January attempt again 10 question papers were held, and in April also 10 question paper were held. So clearly the weightage in January attempt was way too less than in April attempt. Okay. So what is my prediction? My prediction is that application of derivatives is again a high weighted chapter. This is just an exception. So you can expect 1 to 2 questions from this particular chapter definitely. Okay. So let us see that what kind of questions JEE Main asks from this particular chapter. Okay. So let us dive into the very first question, and here it is. Okay. So this is a typical question, I would say, that these type of questions were very popular in functions chapter. Yes, they used to talk about calculation of range of these type of functions. Okay, so basically there is some application of derivatives involvement in this. Okay, so minimum and maximum value or range of a function will only be obtained once you tap the nature of that graph, whether it is increasing or decreasing or combination of increasing and decreasing. Okay, so let us understand. So here we have fx, which is equals to 3 root x minus 2 plus root 4 minus x, right? And we are here for minimum and maximum values of f. Okay, all right. I guess we should differentiate this function to see that what nature this function is having. Okay. So first of all, before differentiating, let me just tell you, because there are two square roots involved. So obviously domain, calculation of domain is very important. So let's do that. So x minus 2 should be non-negative, and 4 minus x should also be a non-negative quantity. What does that mean? That x should be greater than or equal to 2, and x should be less than or equals to 4. What does that mean? The domain of this is 2 to 4. Okay, so you can only talk about this particular range. You cannot put any value between apart from this interval. Okay, so we have a very small interval. What is happening between 2 to 4 with this function? That's what we need to know, and application of derivatives will help us. That means we have to differentiate. We need to check the critical point, whether it is having maxima or minima or not. Okay, so yes, fx is equals to this. So f dash x, let's differentiate. So this is 3 root x minus 2, derivative will be 2 root x minus 2, plus we are having root 4 minus x, derivative will be 1 upon 2 root 4 minus x, and derivative of 4 minus x will be minus. So that's why minus. So this is your f dash x. To get the critical point, we have to equate it to 0. Okay, let's do that. So 3 by 2 root x minus 2 will be equals to 1 upon 2 root 4 minus x. 2 cancel. 3 root 4 minus x will be equals to root x minus 2. Square both the sides. 9 times 4 minus x will be equals to x minus 2. And this is going to become 9 4s are 36 minus 9x equals to x minus 2. So 38 is equals to 10x. X is equals to 3.8. Okay, all right. Now that means there is a critical point as at x equals to 3.8. What does that mean? Critical point means f dash x is becoming 0. That means whether if like there are two possibilities. We can have a minima over here. We can have a maxima over here. Okay. And it can be a thing that it is not having any extrema, neither minima nor maxima. But potential candidate for maxima and minima is at 3.8. How to know whether it is a minima or maxima? To put a critical point on the number line, that is x equals to 3.8. Now, what you need to do is in f dash x only, you have to determine the sign of f dash x before 3.8 and after 3.8. And also, let's not forget, we are only concerned about the interval 2 to 4. Okay. So why not I do one thing? Why don't I do one thing? I put x equals to 3 in f dash x. Okay. I want f dash 3 value. Can I get f dash 3 value? So f dash 3, if I just want to get, so let's put the value over here. It is going to be 3 by 2. And the moment you put 3 over here, so it is 1. Okay. Minus 1 upon 2 root 4 minus x. That is going to be again 1. Okay. Interesting. That means the calculations are very easy. So clearly 3 by 2 minus 1 by 2 is 2 by 2. F dash 3 is coming out as 1, which is a positive quantity. So before 3.8, we are getting a positive quantity. After 3.8, if you put any quantity, let's say 3.9, so it is very clear you're going to get a negative quantity over here. So what does that mean? Your graph is increasing in this interval and your graph of fx obviously is decreasing in this interval. So if you want to plot the graph of f of x, it will look like, so yes, so this is 2, this is 4, and this is 3.8, this is your 3. Here you are obviously getting, so increasing then decreasing, so you're going to get maxima. So the graph will look like this. Okay, there is a maxima at x equals to 3.8. So now just tell me that, okay, and also your graph can also look like this. It depends, right? So maxima is fixed, whether a green colored graph is yours, whether or a red or white color. What is the difference? So in white color graph, we are showing that x equals to 2 has the lowest value and 4 has a slightly higher value. And a green color graph is having f of 2 has a higher value and f of 4. That will depend. That we have to calculate. Chalo. So we want actually, we want 3 values. Okay. So let me just draw a table over here. Yes. Putting x, getting fx. Put x equals to 2. The moment I put x equals to 2, what do I get? So 3, 2 minus 2, 0. This is gone. 4 minus 2, root 2. You're getting root 2. The moment you put x equals to 4, what will you get? The moment you put 4, this time, this will become 0. And this is 3 root 2, right? So 3 root 2. So obviously f of 4 is having higher value. So clearly which graph is correct? The white colored graph is correct. Okay. That means f of 4 is relatively higher. Okay. And here we are having a local maxima and global maxima as well. Both. Okay. And 3.8 pe what do I get? So let's put 3.8 quickly. So yes, f of 3.8 will be equal to 3 root 3.8 minus 2 is 1.8 plus 0.2. If you solve it, this is going to be 18 by 10, 9 by 5. Root 9 by 5 is what? 3 by root 5. Correct. Plus, this is 1 by root 5. 2 by 10, 1 by 5. 3 3 is 9, 10 by root 5. Correct. This is 10 by root 5. If you rationalize, you are going to get 2 root 5. 2 root 5. Perfect. Now, out of these three values, just tell me. Maximum value obviously 2 root 5, right? So, beta is 2 root 5. What about alpha is minimum? So, root 2. Root 2 and 2 root 5, 5, 5. Root 2 and 2 root 5, correct? So, alpha square plus 2 beta square will be what? Tell me. Alpha square will be root 2 ka square plus 2 root 5 ka square multiply 2 because 2 beta square, right? So 2 plus, this is 40. 42 is the answer, yes. Option A, 42 is correct answer. Okay. So I would say this is a standard problem and you have to understand whenever you see this template, this is a template based question. Whenever you see this type of problem, you have to apply the same method. Okay. Domain calculation, then you have to get uh, critical points. Then you have to understand whether your function is increasing, where your function is increasing, where it is decreasing. Plot the graph and then think. Okay, so plotting graph will help. Okay, this either these two out of x equals to 2 and 4 will give you the minimum value and maximum, so definitely 3.8. First question done nicely. Okay, all right. Now, next question. Now, this is basically based on mean value theorem. Mean value theorem. Okay. Before diving into the question, let me just tell you about mean value theorem. So, mean value application of mean value theorem. So, theorem says that if you are having a continuous and differentiable function, and if you are having fx equals to 0 is having suppose n roots, okay, so that means continuous and differentiable. So what is happening? Continuous and differentiable, that means there is no sharp corner. Okay, so n roots, suppose n is equals to 5, let's say 6. Okay, so 6, that means this is how it is going to become: 1, 2, 3, 4, 5, and 6. Okay, in a particular interval, if this is happening, then it says f dash x equals to 0 will have n minus 1 roots in that interval. Ma'am, but how? F dash x ka graph, if I try to plot, just tell me. I don't want to plot the complete graph, but the idea of it. Just tell me, fx is this. Now, this point, this is what? Local maximum. Local maximum means what? F dash x will become 0 at this point. F dash x will become 0 at this point, and this point, and this point, and this point, and this point. How many? 1, 2, 3, 4, 5. Basically, a horizontal tangent. So at 5 points, you can clearly see your f dash x is becoming 0. This is the graph of f dash x. So here it is 0. Then next it is 0 over here. 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 So again, if you draw the graph again, because f dash x is also continuous, if f dash x is continuous and differentiable, then the similar type of graph you have to draw. Now again, tell me, f double dash. So local maximum, local minimum, local maximum, local minimum. So if you plot the graph of f double dash x, then what will happen? You will get a 0 over here, you will get a 0 over here, you will get a 0 over here, you will get a 0 over here. So just tell me, if 6 roots were there for fx, then 5 roots were there for f dash x. Minimum, I'm talking about the bare minimum thing. It can have max or more than 5 also. But bare minimum, this graph should be there. 4 roots clearly will be there. And if your f triple dash is also, so this is how it is, right? So this will go, but the condition, continuity and differentiability should be at point, on point. Chalo. So now this, it will be applicable in question number 2. Okay, let me just check once whether it is recording. Yeah, it is recording. Sorry. Yeah, perfect. Yeah. So now f is such that R2R be a thrice differentiable function. Thrice differentiable. Can you see? F triple dash is also the same. Okay. Now f of 0 is 0. F of 1 is 1. F of 2 is minus 1. F of 3 is 2. And f of 4 is minus 2. Okay. So let me just plot the graph of this and let us understand what is happening. F of 0 is 0. Perfect, ma'am. F of 0 is 0. F of 1 is 1. F of 2 is again then minus 1. Then f of 3 is 2. And this is your next is minus 2. If you join this, because continuous and differentiable, so you have to join like this. You have to make the graph smooth. Oops. Yes. That's it. Okay. Right. So can you see that your fx is having how many roots? So ma'am, 1, 2, 3, 4. That's it, right? 2 and minus 2 again. Okay. 1, 2, 3, 4. 4 roots, right, 4 roots. Obviously, f dash x will have 3 roots, right? Okay, all right. Now, what is this? We are looking for minimum number of zeros or roots of this expression. Now, this expression, it will depend on your observation skills, by the way. So, this we will get by differentiating something, okay? How to get this? How to get this thing? 3 f dash f double dash f triple dash. Understand? Now let me tell you a function hx which is fx f dash x. Let me differentiate it once and get back to you that whether we have a correlation between this and my hx or not. So okay, let's differentiate. H dash x will be f dash x product rule f dash x. So I have differentiated the first function. This is your first, this is your second. And f dash x is kept constant plus this time fx is kept constant f double dash x. So basically h dash x will be f dash x whole square plus fx f double dash x. Now one more time let me differentiate. So h double dash x will be, this is 2 f dash f double dash plus. Now again product rule, fx is kept constant. Derivative of f double dash will be f triple dash plus. This time fx is differentiated. So f dash x and f double dash x is kept constant. If you see that these two can be added. These two are what? This is 2 f dash f double dash and the second is f dash f double dash. So this is coming out as 3 f dash f double dash plus f triple dash. This is your h double dash x, right? So much dash dash dash. Okay. All right. And it is exactly matching with our expression. Okay. All right. So now if this is your hx, if hx is having n roots, then h dash will have n minus 1 roots and h double dash will have n minus 2 roots. Perfect. So we just need to know n. Now hx is having how many roots? Basically hx is having how many roots? So that means we are talking about when hx is becoming 0. Hx is becoming 0 when your fx and f dash x both are 0 individually. Fx is becoming 0 4 times. F dash x is becoming 0 3 times. So overall 7 times. So it is having 7 roots. So it will have 6 roots. And overall we are having finally 5 roots of this expression. 5 is absolutely right. I hope that this question is crystal clear to you. All right, let's now move on to the next problem. All right. So in this question, they are saying that let a rectangle ABCD of sides 2 and 4 be inscribed in another triangle PQRS such that the vertices of the triangle ABCD lie on the sides of rectangle PQRS. Okay, what is happening? So let me just draw. Okay. So there is a triangle PQRS, which is a bigger triangle. Okay, let me take a PQRS. Let me take a PQRS. Okay, hold on. Yes. Yes. Okay, hold on. No, I am not happy with this. Still not happy with this. Hold on, let me draw it nicely. Okay, I guess. Okay, yeah. So we have a triangle. You can see. No, 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 no. What is happening? Okay, yeah. We have a triangle, as you can see. Then this is a PQRS. PQRS. Then we have a rectangle. So this is a rectangle. Okay. So this is a rectangle PQRS. Now my ABCD is inscribed in this triangle. So let me just draw the ABCD inside this. Okay. ABCD will look like this. Thoda sa we need to adjust. Okay. No issues. All right. So thoda sa we need to adjust. Yes. Perfect. Okay. So this is your ABCD. This is your ABCD. Okay. All right. Now, the sides are already given for ABCD 2 and 4. So suppose this is your 4 and this is your 2. Again, this is your 4 and this is your 2. Perfect. Now what they are saying is ABCD is inscribed in rectangle PQRS such that vertices lie on the sides of PQRS. So vertices are lying on the sides of PQRS. Perfect. Perfectly drawn. Okay. Let A and B be the sides of the rectangle PQRS. So yes, we are talking about sides of PQRS when the area is maximum. So we need to maximize the area. Okay, to maximize the area, what we need to do? We need to first calculate the value of area. Number one thing. Once we have calculated, now we need to make sure that the area is maximum. So whenever we need to maximize any quantity, you just differentiate and make it 0 to get that condition. Okay. So finally, we will calculate area. Then dA by basically the derivative. Or we can directly write, right now I'm not sure, but A dash. A dash is 0. Okay, with respect to what? That we need to check. And now we will assume some variables. So area should be 0. Area, derivative of area should be 0. And using this thing, we will calculate the sides accordingly. Okay, I guess the agenda is clear. Now, just understand what is happening over here. So can I take this as theta? This is theta. This is obviously 90. So this will be 90 minus theta. Yes. Okay. This is again 90. Okay, so 90 minus theta, 90. This will give me theta. So that sum of this angle, this 90 and this, sum of these three is becoming 180 degree. Perfect. Now if this is again theta and this is obviously 90 because of the rectangle, this will become 90 minus theta. Right? And next, again, this is again 90. So 90, 90 minus theta, the remaining would be theta. How come? Because the sum of linear pair basically. So again, now the same thing. This is 90 minus theta. Perfect. 90. This is theta. This is 90. 90 minus theta. This is 90. Okay. So angles are done. Now start assuming the sides. Okay. So first of all, this is a right angle triangle. If you can see this, this triangle is a right angle triangle. Can you see this? Yes. CDR. If you're not seeing, CDR is a right angle triangle. So in this, if this hypotenuse is 4, so this is base, this will be 4 cos theta. Perfect. Similarly, if I talk about this, if this is 2, so this is 2 cos theta. Right? If I talk about this is 4, so this is again 4 cos theta. And if I talk about this is 2, so 2 cos theta. Correct? And now, what about this? CS. So if this is 2, this will be 2 cos 90 minus theta. That means 2 sine theta. Right? Again, this is 2 sine theta. Again, this will be, now what about this? This is 4 sine theta. And this is again 4 sine theta. Now you know the sides, right? So in here, A side will be 2 sine theta plus 4 cos theta. B side will be 4 sine theta plus 2 cos theta. Correct? So A and B. Both the sides we have obtained. Now area will be 2 sine plus 4 cos and 4 sine plus 2 cos. Correct? Now we need to differentiate obviously with respect to theta. Okay? So differentiate. So dA by d theta. For that, let us do one thing. Let us just multiply it. Let us just multiply it. Okay, first. So this is 2 I can take common from here and here. So 4. Area will be equals to 4 common. This is sine theta plus 2 cos theta. And this is cos theta plus 2 sine theta. Now multiply. 4 sine cos plus 2 sine square plus 2 cos square plus 2 to the 4 sine cos. So this is going to become 4. 5 sine cos plus 2. This is your area. Now differentiate. Area is 4, 2 plus 5 sine theta cos theta. Now differentiate. dA by d theta should be 0. Okay, so 2 ka derivative is 0 plus 5. 5 sine theta cos theta basically can be written down as, so this is actually sine 2 theta by 2. Now differentiate. So this is cos 2 theta by 2 to is there and one more 2 will be there. So obviously it is 0. So cos 2 theta becomes 0. That means 2 theta is 90 degree. Theta will be 45 degree. The moment you get 45 degree, now you can clearly get A and B, right? So A will be 2 sine 45 degree plus 4 by root 2. So this is 6 by root 2. This is your A. Similarly, B would be 4 by root 2 plus 2 by root 2 again 6 by root 2. Okay, so this is basically becoming a square. 6 by root 2, 6 by root 2. 6 by root 2 plus 6 by root 2 is 12 by root 2 ka square will be the answer. 144 by 2. That is going to give you 72. Option A is absolutely right. Okay. So this question also done nicely. Now we are having another question. For the function fx equals to sin x plus 3x minus 2 by pi x squared plus x. Okay, so this is a big function. What they are asking about is f is increasing in what interval and f dash is decreasing in what interval. Okay, so basically we have to figure out f dash and f double dash both. Okay, so fx is what? Sin x plus 3x. And then we have minus 2 by pi x square plus x. X belongs to 0 to pi by 2. Okay. Now differentiate. F dash x cos x plus 3 minus 2 by pi 2x plus 1. This is your f dash. Okay. All right. ठीक है. Okay. So we need to check f dash x is positive in 0 to pi by 2 or not. If it is positive, then only f is increasing. Okay, let's do one thing. ठीक है. So just tell me if x is lying between pi by 2 to 0, right? So 2x plus 1. 2x will be pi to 0, right? I'm talking about this. I have 2x plus 1 in my mind. Now plus 1. Adding 1. 2x plus 1 is pi plus 1. And now you multiply 2 by pi in that. So 2 by pi, 2x plus 1 and 2 by pi, pi plus 1. Okay. So basically this whole thing is lying between 2 by pi, 2, this is 2 plus 2 by pi. Okay. So this quantity will lie between what? So this is basically 2 by pi, which is a positive fraction, by the way. Okay, positive fraction, and this is 2 plus 2 by pi. Okay. So if I talk about cos x plus 3, okay, cos x plus 3 between 0 to pi by 2, it is going to become 0 to 1. This is anyway positive, 0 to 1. So this, basically what I'm trying to figure out is whether this f dash x is positive or not. So let us put cos x equals to, okay. Okay, let's do one thing again, cos x plus 3. So cos x plus 3 belongs to 0 to 3 to, yeah, 3 plus 0 to 3 plus 1. Basically, this is 3 to 4. 3 to 4. Okay, so 3 comma 4. And this is lying between 2 by pi comma 2 plus 2 by pi. If you subtract these two, now basically 3 minus 2 by pi or 3 minus this is always positive. This thing is always positive, right? Because anyway, this is always cos x plus 3 will always be greater. That's what I'm trying to say. Okay? And now, hold on. Let me just give you a clarity on this. Now cos x plus 3 greater than 2 by pi 2x plus 1. Okay? So what I'm trying to say is no matter what value you put, this is always greater. How, ma'am? Because you tell me. This is the left hand side is from 3 to 4 and the right hand side we just calculated 2 by pi to 2 plus 2 by pi. So minimum value is 0 point something and maximum value is 2 point something. Just tell me 3. Left hand side minimum value is 3. Now 3, if we fix left hand side minimum as 3, so just tell me that this left hand side is always be greater, right? That's why f dash x is always positive. Obviously this, in this interval I'm talking about. So definitely this is correct. Statement 1 is coming out as true. Now differentiate one more time. So f double dash x we need to differentiate, right? Cos x ka derivative is minus sin x, 3 is 0, minus 2 by pi, and this is 2. Yes, so this is going to become minus sin x minus 4 by pi. Obviously, sin x is going to be positive in this interval, first quadrant. So obviously f double dash is negative. That means f dash x is decreasing function. If f double dash is negative, that means f dash is decreasing function. So this is also true. Option D is absolutely correct in this particular question. All right. Now we are having another question. The maximum and the minimum values of this. Okay. Chalo. Let's understand this. Maximum and minimum value. So I can clearly see that this is actually it feels that somebody has, if I just put it as y, just put this as y. So don't you think this thing is distance, square of distance between, square of distance between x comma y and 4 comma 7. Don't you think? It feels like, right? So if I just calculate distance between x comma y and 4 comma 7 and square it, I will get this only, right? What does that mean? That y is square root of 8x minus x square minus 12. Square both the sides. Although y is always positive over here, so we'll keep that in mind. But to understand this graph, now we have to square, right? So this is actually what? Tell me. Tell me, this is a circle. Actually, this is a circle, but with y is never negative. Okay, so this is a semicircle. Let me plot this circle over here. Okay, let me draw it nicely. How to draw semicircle? Okay, like this. Fine. And okay, can I? No, I can't. Oh, oops. हाँ, ठीक है. तो now I just have to remove. I can't remove. But what I can do one thing. I am finding all the hacks. I will remove it. I will fill the black color in this circle. Okay. All right. Yes. So it looks perfect semicircle. Now this circle is having 4 comma 0 as the center. So this is 4 comma 0 absolutely. 4 comma 0 is the center, right? This is your x-axis. 4 comma 0 will lie on x-axis obviously. And what is the radius? Radius will be square root of 4 ka square is 16 minus 12. So radius is 2. Okay, the radius is 2. Okay. So this length is 2. Perfect. Now we are looking for let the maximum and minimum values of. So what are we looking? Understand. X comma y will lie on this semicircle and there is this point 7 comma 4. So we are looking for distance between 7 comma 4 and a point on this circle will be a random point x comma y. Now this is a moving point on the circle. We have to think this x comma y, where should it lie so that my distance is maximum, and x comma y, where should I lie so that my distance is minimum as well. Okay. So clearly minimum distance between point and a circle will be lie along the common normal. Yes. So this will be the point. This will be the minimum distance, small m. So small m will be, if this is let's say O and this is let's say P, small m will be OP minus radius of the circle. OP, what is OP? Very clear. OP is nothing but 7 minus 4 ka square. So 9 and 4 4 is 16. So OP is 5 actually. OP is 5. Hai na? If you calculate OP over here, this is 7 minus 4 ka square plus 4 minus 0 ka square. So this is going to be 9 plus 16, so 5. Okay, OP, so 5 minus 2, that is going to be 3. Small m is going to be 3. Okay, so 3 ka square, capital M. Now I want my point to be as far as possible. So now this is a semicircle. Suppose it would have been a full circle, no? Then the maximum distance ke liye the point should lie again along the common normal. Here should be the point. So maximum distance from P will be what? PO plus this radius. PO plus this radius. Okay. All right. So this is your radius here. OP minus R will give you this distance. Correct. And OP plus R will give you maximum. But this time I can't put my point over here because I don't have a point. I only have a semicircle. So now the next option is I will keep my point over here. So this is 2 comma 0, right? The maximum distance will be what? Tell me. That is going to be directly, you can just 7 minus 2 ka square plus 4 ka square. So m will be equals to square root of 25 plus 20, that is m square is equals to 45. 45 minus this. 45 minus 9. 45 minus 9. 45 minus 9. 45 minus 9. Hold on. 7 minus 2, 5, 25. 4 minus 0. Hold on. 7 comma 4 and 2 comma 0, right? So 25 plus, okay, all right. 25 plus 16, no, sorry. 25 plus 16, right? So this is 41, 41, 41. 41 minus 9, yes, 41 minus 9. So m ka square, right? So this is 3 ka square. So 41 ka square, right? Right. M is equals to 41. 41 ka square minus 3 ka square. Yes, yes, yes. Finally, we are right. 41 minus 3 and 41 plus 3. This will be your answer. 41 plus 3 will be 44. 41 minus 3 will be 38. So hold on. Hold on. Hold on. So m square is 9, correct? Take a second. Give me a moment, huh? m square will be 41 ka square minus small m. Hold on, let me get this. So this is going to become 7 minus 4 ka whole square, that is 3 ka square. Okay, so this is coming out as 5. 5 minus 2, that is 3. M square is 9, right? M square is 9. Is it 9? 7 minus 4 is what? 3. 9 plus 5 minus 2 is 3. Okay. So this is 3 now. 41 square minus 3 square should be your answer. Okay. 41 square minus 3 square should be your answer. Am I wrong in this? 3 ka square plus 4 ka square. 9 plus 16 ka root. So 5. 5 minus 2 is equals to 3. M is 3. Minimum distance is 3. Oh, we are talking about square of the distance. Hold on, I have messed it up. Okay. All right. So I guess you guys understood what has just happened. So we are here to look for, so small m is square of minimum distance, right? Capital M is square of maximum distance, right? So square of minimum distance, the minimum distance is 3, right? Minimum distance is 3. So this is going to be 9. Maximum distance is what? So distance, this is not m. So distance is root 41, correct? Square of this will be 41. Now we are looking for m square minus m square. So 41 square minus 9 square. Now if you solve it, 41 plus 9 and 41 minus 9 will be your answer. That will give you 50 into 32. 1600 will be the final answer. Perfect. Got it, got it, got it. I guess you're sorted now. Chalo. Clear. Now we are having another question. Basically, this category is having two similar type of question. Similar, not exactly same. Okay, both are having same function, but the way of asking is very, very different. Okay, the interval in which fx equals to x raised to power x is strictly increasing. I believe this is the easiest question in application of derivatives. So again, we need to figure out where your f dash x is greater than 0. X raised to power x is your fx, right? We need to differentiate. First of all, take logarithm and then differentiate. So 1 upon fx, f dash x is constant, log x derivative is 1 upon x plus log x is constant, x derivative is 1. So f dash x is equals to f of x 1 plus ln x. F dash x is equals to x raised to power x 1 plus ln x. By the way, this is a very popular function. X raised to power x derivative, you all should know that x raised to power derivative is x raised to power x 1 plus ln x. Now this should be positive. This is always positive. Exponential function is always positive. So 1 plus log x should be positive. Log x should be greater than minus 1. Log x should be greater than minus log e. Log x should be greater than log 1 by e. X should be greater than 1 by e is your answer. That means option 3 is absolutely right. Okay. All right. So this is the question. Now let us move on to the next problem. Okay. Next problem says fx is equals to this. X greater than 0 attains the maximum value at x equals to 1 by e. Then, okay. So we need to figure out whether this is greater, this is less, and so on. ठीक है? ठीक है. Chalo, let's do it. Obviously, the question suggests that e raised to power pi is less than pi raised to power e. So the question is already giving the option either A or B is correct, right? They cannot be equal to each other, right? So either one is greater or other is less. So that means these two we can straight away eliminate. Just tell me that if I give you 1 greater than 2, B option 2 greater than 1. So don't you think that between these two, one out of these two should be correct? Will you see option C and D? No, no, right? Because you know that if A is wrong, then B should be correct. Okay, that's the case. That's why I'm saying that C and D I'm not even looking at. Okay, now this is your fx. Now we have to understand whether your fx is increasing or decreasing. Okay, let us first talk about f dash x. That is going to become, for that let's take logarithm on both the sides. Log of f of x is equals to 2x and log 1 by x. Log fx is equals to 2x log of x, negative sign. Now differentiate 1 by f dash is equals to minus 2x, 1 upon x, minus 2 log x, that's it. Okay, so f dash will be equals to f. F is what? 1 by x raised to power 2x, minus sign if you take common. This is going to become minus 2 if you take common. Minus 2. 1 plus ln x. Okay. So what does that mean? From previous question, we realized that f dash x is, so this is anyway positive. Minus 2 is already there. So for x greater than 1 by e, right? For x greater than 1 by e, my function is decreasing this time. Okay, all right. Function is decreasing for x greater than 1 by e. So now that you have understood that your function fx is decreasing when your x is greater than 1 by e, and when x is less than 1 by e, it is increasing, right? So 1 by e is your critical point. So 1 by e. So yes, the function is decreasing. Here the function is increasing. We don't know whether there is sharp corner or not, but yeah, 1 by e. This is your e, this is your pi, right? And what about 1 by pi? Obviously, 1 by pi is 1 by 3. This is 1 by 3 something, this is 1 by 2 something. 1 by 3 will be smaller. 1 by 2 will be the larger, okay? So 1 by pi is less than 1 by e, right? So the value at 1 by pi will be lesser obviously than 1 by e, right? Now can I just use f of x is what? 1 upon x raised to power 2x, correct? So this is going to become 1 upon pi raised to power 2 pi less than 1 upon e. Oops. Okay. We are putting x equals to 1 by pi, right? Right. So this is going to be pi raised to power 1 upon 2 pi less than e raised to power 1 upon 2e, right? Putting x equals to 1 by pi and 1 by e respectively. So 2 cancel. Now what I'm going to do is I'm going to take both sides. I'm going to apply a power. So pi raised to power 1 by pi and e raised to power 1 by e. Can I do one thing? I can take power pi e, which is a positive power which is greater than 1. Sign will not get affected. So pi cancel, e cancel. Obviously, e raised to power pi is coming greater than pi raised to power e. Okay. So yes, I guess which option is correct? E raised to power pi is greater than pi raised to power e. Option 2 is correct. Good question. Okay. All right. Now we are having a next question which says, fx is given and we need to figure out whether your fx is 0 for only one value in this or fx is decreasing. Basically, f dash x will tell us everything. Critical point. So this is minus sin x minus 1. Minus sin x minus 1. Now can you 1 plus sin x? So this is always negative. So your f dash x is always decreasing function. Okay. Let's try to plot decreasing function between obviously 0 to pi. So 0 to pi mein your fx is a decreasing function. If you put 0, f of 0, tell me. F of 0 is 1 minus 0. F of 0 is cos 0 is 1 minus 0 plus 1. So it is starting from 2. And f of pi, because it is a decreasing function, pi. Cos pi is minus 1 minus pi plus 1. So it is a negative quantity. So this is your graph, right? It is a decreasing function. So this is your graph. So obviously, clearly we can see that there is one root. So fx is equals to 0, only one value. It is absolutely right. Statement 1 is correct. Fx is decreasing in this and increase. So this is wrong. This is wrong, right? So S2 is wrong. S2 is wrong. Only S1 is correct. So option 4 is absolutely right. Okay, good question. Again, easy question. Chalo, next question. Fx equals to this, the number of points of local maxima in the interval 0 to pi. Okay, 0 to 2 pi. So to local maxima, f dash x will be equals to 0. Okay, f dash x. Tell me. So ma'am, 4 3s are 12 cos square x plus 3 6 root 3 cos, oops, साइन कौन लगाएगा, cos square x minus sin plus 3 6 root 3 cos x minus sin. That's it. Yes. So this is how it is. Now take common. 6 cos x and minus sin x can be taken common. So you are left with 2 cos x plus root 3. Make it 0. So this will become 0 when cos x is equals to minus root 3 by 2. Now all sine tan cos. Tell me. Second and third quadrant. Okay. So pi minus pi by 6, pi plus pi by 6. X equals to. Okay. And then x equals to cos x becomes 0 when your x is pi by 2 and 3 pi by 2. Sin x becomes 0 when your x is pi. So just plot all the critical points. There are 1, 2, 3, 4, 5 critical points. Okay. So, and 0 is not included. So this is your 0. 0 is not your critical point. 2 pi is also not your critical point. Now, I'll change the color so that you understand it better. Pi minus pi by 6. So first of all, first is pi by 2. Pi minus pi by 6 is 5 pi by 6. Then pi. Okay, not pi. 3 pi by 2. Then pi. Then it is 7 pi by 6. Just tell me 1, 2, 3, 4, 5. 5 critical points already plotted. Now, just start calculating this. Okay, so 0 to pi by 2 may understand. First quadrant is there. First quadrant may cos and sine both are positive. Okay. What about, and this is a negative sign. What about 2 cos x plus root 3? So since cos x is also positive, this is also positive, but this is going to give you a negative sign. Now in this is your second quadrant, right? And this is your, yeah, this is your second quadrant. Pi by 2 to 5 pi by 6, right? Second quadrant mein cos becomes negative, so that this and this becomes minus, and cos x becomes positive. Sine is anyway positive. What about this? Now, cos is negative, right? So cos is negative, that means, but cos is negative, but it is not causing any effect. So this is a positive quantity. Now 5 pi by 6 to 3 pi by 2. You put any value, you will get your answer. You want to put, okay, there is one mistake. Okay, so this is pi and this is 3 pi by 2. Now it's perfect. Now this is your second quadrant. This is again your second quadrant. But here you will get a negative value, right? Okay. Because cos x is changing, right? Cos x was greater. Cos x was coming greater before. Now cos x has changed. It is becoming less than root 3 pi by 2. Now what about this? Pi to 3 pi by 2, basically third quadrant. Third quadrant mein again sine cos both are negative, so there is this negative sign. Baki, what about 2 cos x plus root 3? So it is going to give you a positive sign. Then it is going to give you a negative sign. Then it is going to give you positive signs. Alternate positive minus will happen. So now just if you plot the curve, so this is decreasing, increasing, decreasing, increasing, decreasing, increasing. Positive. F dash x negative means your f is decreasing. So this type of graph will have a minima, again minima, again minima. But what about maxima? This will have maxima, maxima. So there will be two maximas over here. One will be at 5 pi by 6, another one will be at 3 pi by 2. Hold on, pi plus. There is one more thing over here. So this is 7 pi by 6 and then 3 pi by 2. Yeah. So another maxima will be at 7 pi by 6 and this is 5 pi by 6. Okay. 5 pi by 6, 7 pi by. How many local maxima? The two local maxima in this particular case. Okay. All right. Now let us move on to the next problem. Here we just need to know the critical points. That means critical points means f dash x either 0 or not defined. F dash x equals to, now just product rule, x minus 2, 2 by 3. 2x plus 1 derivative is 2 plus. This time 2x plus 1 kept as it is and derivative of this will be 2 by 3 x minus 2 raised to power minus 1 by 3. Correct? So f dash x will be equals to 2 x minus 2, 2 by 3 plus 2 by 3, 2x plus 1, and this is going to be x minus 2 raised to power 1 by 3. What we can do is we can simply take LCM. X minus 2 raised to power 1 by 3. So if you take LCM, so this is going to be 3 to the 6, x minus 2. 2 by 3 plus 1 by 3 will be 1 plus 2, 2x plus 1. Now 6x plus 4, 10x. Minus 12 plus 2 minus 10. X minus 2 raised to power 1 by 3. Clearly x equals to 1 and x equals to 2 both are critical point. Here f dash is becoming 0 and at x equals to 2 it is becoming not defined. So how many critical points? 2 critical points. Okay. All right. So yes. Now we are having another question which is question number 11. So 5 more questions are left. 5 more questions are left. Okay. If the function fx is this, has a local maxima at x equals to alpha and a local minimum at alpha square. Okay, so these two are actually critical points. So that means f dash x equals to 0 will happen at x equals to alpha comma alpha square. Let's differentiate. Okay. So f dash x equals to 0. So 3 to the 6. Correction, there is correction. This in the question it is 9ax square. No, it is misprint over here. F dash x 6x square, 3 to the 6x square minus 18ax plus 12a square. This is your f dash x. Okay. Now if it is becoming 0, so again quadratic equation is having two roots, alpha, alpha square. Okay, so this is the quadratic whose roots are alpha and alpha square. So we are actually looking for what? We are actually looking for a value of either a or alpha, right? Okay. So now just tell me, sum of roots is equals to minus 18, minus of minus 18a by 6, that is 3a. Product of roots will be equals to 12a square by 6, so 2a square. Okay. Alpha cube is equals to 2a square. Now we need to establish a relation between alpha, basically these two equations. I have to make sure that I use alpha plus alpha square. Alpha plus alpha square is equals to 3a and alpha cube is equals to 2a square. Can I do one thing? I just put the value of a is, the value of a becomes alpha square plus alpha by 3. Let us put it over here. Okay. So the value of alpha cube will be equals to 2a square. So alpha square plus alpha upon 3 ka square. Okay. Okay, let's solve it. So alpha cube is equals to 2 by 9 alpha plus alpha square ka square. Alpha cube. So 9 alpha cube 2. It is going to be alpha square plus alpha power 4 plus 2 alpha cube. Clearly alpha cube can be cancelled. 9 is equals to 2. 9 alpha. Alpha square can be taken common. 1 plus alpha square plus 2 alpha. Alpha square is taken common from both sides. Okay. This is 1. This is 1. So this is going to become what? 2 alpha square plus 4 alpha minus 9 alpha minus 5 alpha plus 2 equals to 0. If you solve this, you're going to get two values of alpha, 2 comma half. Okay. Now just tell me 2 comma half. If I take alpha equals to 2, then what will happen? So as per the question, they are saying that this function is having local maximum at alpha and minimum at alpha square. This is a cubic with leading coefficient positive. You know that. Cubic with leading coefficient positive looks like this. Okay. Right. Basically, minus infinity pe you are going to get minus infinity, plus infinity pe it will reach plus infinity. This is how it is. Now just tell me if alpha is 2. So this is 2. So this is your maximum you will get at 2. Minimum you will get at 4. So this looks fine. Okay. Maximum at 2, minimum at 4. This is what they are saying. Maximum at alpha, minimum at 4. But in case of alpha equals to half, it is not possible. Just tell me. This is your graph. If this is 1 by 2, this cannot be 1 by 4. Right? So this is incorrect. That's why alpha is equals to 2 is accepted. 1 by 2 is not accepted. So if alpha is 2, the 2 comma 4 are the roots of the equation. 2 comma 4 are the roots of which equation? Just tell me. First equation, right? X square minus 6x plus 8. It is not satisfying in second, third and fourth. Very easy, right? Not very easy, but yeah. It is like tricky question. But if you understand the whole picture, the solution is not that difficult, okay? Chalo. 4 more to go. A be the region enclosed by the parabola y square equals to 2x. And the line x equals to 24. Then the maximum area of rectangle inscribed in the region A. Okay. A be the region enclosed by the parabola. Okay. So let's do one thing. This is a rightward opening parabola. Rightward opening parabola. The parabola looks like this. Okay. Y square is equals to 2x. Line x equals to 24 looks like this. Then the maximum area of rectangle inscribed in the region A. So region A be the region. So this is the region. So this is the A region, right? Okay, so inscribed, let's draw a triangle over here and calculate the area and maximize it. So obviously, so if I talk about this point, obviously 24 comma, let's say A will be this point, 24 comma A. Again, this is again 24 comma minus A by symmetry. But anyway, 24 comma A, let's take this. And what about this point? This point will be, y coordinate will be same. So this is A. So this is lying on parabola, right? So if y is A, what is x? So y is equals to A. Y coordinate will be same on this line, right? Y is A. So A square by 2 is your x. So A square by 2. Now tell me the length of and breadth. Area of triangle is length into breadth, right? Length, that means this. Basically multiplication of both the sides. So this will be what? Just tell me. So this is, if this is A, this will be also be A. Now this length is A basically. So 2A. 2A is the complete length of one side, okay? And then what about this? This is going to be 24 minus A square by 2. That's it. Now multiply. So this is going to be 48A minus A cube. Now differentiate. So dA by dA, because we need to maximize, right? 48 minus 3A square should be equals to 0. A square is equals to 48 by 3. A is equals to 4. Now what are they asking? Maximum area. Maximum area is when you get A is equals to 4. Area will be 48 into 4 minus 4 cube. So 8 fours are 32. 3 carry, 4 fours is 16 plus the 192 minus 64. 192 minus 64 will give you 128 as the final answer. 128 is the absolutely correct answer. All right. So a variable line L passes through the point 3, 5 and intersect the positive coordinate axis at the point A and B. Okay, so basically this is the line, 3, 5 is the point, and this is A, 0, this is 0, B, and we are having 0, 0. Okay, all right, so yes. Now can I write the equation of line? This is going to be x by A plus y by B is equals to 1. And obviously if I talk about minimum area, so area will be what? Half AB. Right, so 3, 5 if I satisfy, it will become 3 by A plus 5 by B is equals to 1. So B if I calculate from here, it is going to be 5 by B is equals to 1 minus 3 by A, and 5 by B is equals to A minus 3. Right, so B will be equals to 5A upon A minus 3. This is your B. So A is equals to 1 by 2 A 5A upon A minus 3. Okay, so it is coming like this. Now let's do one thing. A is equals to actually 5 by 2 A square upon A minus 3. We are looking for minimum value of A square upon A minus 3, right? So let me do one thing. 5 by 2. A square minus 9 plus 9. Can I do that? So this is going to become 5 by 2 A square minus 9. So that will give you A plus 3, A minus 3 plus 9 upon A minus 3. Separated. Okay, these two together, 9 alag. Upon A minus 3, obviously these two are getting cancelled out. So A is coming out as A plus 3 plus 9 upon A minus 3. Okay, very smart thing we are going to do right here. Right, A is equals to 5 by 2, A plus 3. Now, A is equals to 5 by 2, A plus 3 plus 9 upon A minus 3. We are looking for minimum value. What I'm going to do is, I'm going to subtract 3 from here and add 3 to it. So that I can write A minus 3 plus 9 upon A minus 3 plus 6. Can I do that? Minus 3 plus 6 will anyway going to get me this. Why I'm doing this? Because I want to use AMGM inequality. So A minus 3 plus 9 upon A minus 3 upon 2, A greater than equal to G, right? AMGM inequality. Greater than or equal to square root of A minus 3, 9 times A minus 3. Cancel, cancel. So A minus 3 plus 9 times A minus 3 greater than or equals to 6. Okay. So this thing, minimum value of this is 6. So area will be 5 by 2, 6 plus 6, 5 by 2, 6 plus 6, 12. So this is going to be 30. Minimum area of this quantity will be 30. Okay. This is something else that we don't need. So 30, 30, 30, 30, 30. Option A, 30 is absolutely right. Okay. All right. Clear. Let us move on to the next. Let the set of all positive values lambda for which the local minimum of this function satisfies this be alpha comma beta, then alpha square plus beta square. Okay. So local minimum of the function x square plus x plus 2 upon x square plus 5x plus 6 less than 0. Okay. So what they are saying is that local minimum of this function should lie in this interval. Which interval? This interval. So let's solve it. Okay, let's solve it. Okay. So this is going to be x square plus x plus 2 is anyway a positive quantity, right? Yes, this is a positive. So ghost. So x plus 2 and x plus 3 plus some positive quantity should be less than 0. What does that mean? This is minus 3 minus 2. So x belongs to minus 3 to minus 2. So now local minimum of this function should lie between minus 3 to minus 2. Okay. And this condition will give me set of values of lambda. That will be alpha comma beta. Okay. So yes, local minimum. So fx is equals to 1 plus x lambda square minus x cube. This is your function, right? F dash x. So this will give you 0 plus lambda square minus 3x square equals to 0. X square is equals to lambda square by 3. X is equals to plus minus lambda by 3. Okay. X equals to plus minus lambda by 3. Correct. Now, since this is a cubic equation with leading coefficient negatives, cubic equation with leading coefficient negative looks like this. Understand? That means it is having local minima at positive values of lambda. Lambda is positive, so minus lambda by root 3. Minus lambda by root 3 should be a negative quantity and lambda by root 3 should be a positive quantity, right? And as per the graph, negative value should come before and minima is coming before, maxima is coming after as per the graph, because this is the graph of leading coefficient negative cubic equation. So now local minimum is minus lambda by root 3. Minus lambda by root 3 should belong to minus 3 to minus 2. That means lambda by root 3 should belong to 2 to 3. So lambda belongs to 2 root 3 to 3 root 3. That's it. You're done. 2 root 3 ka square plus 3 root 3 ka square. So 4 into 3, 12 plus 9 3s are 27. So 939 is the final answer of this question. Okay. All right. Chalo. So now we are having the last final question of the day, which says set of all values of P for which it does not have any critical point. Okay. Set of all values of P so that this is not having any critical point. What does that mean? F dash x should never be equal to 0 or it should never be non-defined. Okay, so let's calculate f dash x first. P though is a constant quantity. Let's keep it as it is. Sine square 2x minus cos square 2x. Okay. Sine square 2x minus cos square 2x. Actually, this thing is minus cos 4x. This is the direct formula. So derivative of cos is what? Minus sine. So it is going to be sine 4x and one more 4 differentiation ka plus 2 minus p. That's it. This should be 0. So now sine 4x is what? Minus of 2 minus p upon p square minus 6p plus 8, and this is going to be a 4. This is 2 ones are 2 twos are. Sine 4x is coming out as p minus 2, this is p minus 2 and p minus 4. Clearly, p cannot be equal to 2. Okay, if p becomes 2, then what will happen? If p becomes 2, then what will happen? This is anyway 0. This is anyway 0. And yeah, p cannot be. So this is 0, fx. This is also 0. So fx to is, I don't know what is happening with, so fx is becoming say 7 basically. But f dash x is becoming, can you see? If p is 2, then this is 0. This is also 0. So f dash x is becoming 0. No, p cannot be 2. Because if p is 2, f dash x becomes 0. Which we don't want. Which we do not want. No? We don't want any critical points. So first thing is p cannot be 2. Now sine 4x is this. So now I don't want f dash x to be 0. Sine 4x can never be equal to this. Now sine 4x will always lie between minus 1 to 1. So what I need to do is 1 upon 2 p minus 4. The range of this will never lie between this -1 to 1. So basically what I want is this value is always greater than or equal to 1. Okay, or less than or equal to -1. So basically modulus less greater than or equals to 1. This implies p minus 4, 1 upon p minus 4. This implies that 1 upon p minus 4 ka mod is greater than or equals to 2. Okay, all right. Sorry, equal bhi nahi aayega na. Equal, I don't want this to become equal also. Greater than 1. So this is going to be greater than 2. Okay, all right, p minus 4. So clearly p minus 4 ka mod is less than 1 by 2. So p should be less than 4 plus half. So 4 to side, so p should be less than 9 by 2. And from here we can say that p minus 4 should be greater than minus half. P should be greater than 4 minus half, 4 to the 8. P should be greater than 7 by 2. So it should lie between 7 by 2 to 9 by 2. So the interval is 7 by 2 to 9 by 2, correct? So 16 into 7 by 2 into 9 by 2 will be the answer. So this is 4 into 63. That is going to be 252 as the final answer. Okay. So this is the last question. This was the last question, and few things I would like to tell you. Number one, if you have any doubts, you know where to reach out. t.me/Namrata Jaisinghani. Okay. Second, 2024 PYQs, so we are doing live all the PYQs. But if you want to do 2022 and 2023 PYQs, link is given in the description box. You can buy the Tatva books which are having chapter wise. Yes, Tatva books which are having chapter wise solutions of 2022 and 2023 PYQs which are errorless solutions. So I highly recommend that you solve these PYQs, and if you are looking for the source, I am telling you the source. Okay, so two very important things to tell you, and I guess we are done, and I'm gonna meet you in another session. Also, do let me know that next which PYQ do you want. Okay, all right, this is me Namrata signing off.